Welcome back, Chemistry 30. So we've looked at drawing Lewis structures. This section here will look at some rules in drawing Lewis structures for molecules, and hopefully it'll make our lives a little bit easier when drawing Lewis structures and knowing what to look for. So Lewis structures can help us understand the bonding in many compounds and are frequently used when discussing the properties of molecules. For this reason, drawing Lewis structures is an important skill that you should practice. To do so, you should use the following procedure. So first of all, take a look at all of the valence electrons in all of the atoms. So use the periodic table to determine how many valence electrons are in each atom. So of course look at the group number for the representative or the A group, and you can easily get that. If we do have, rather than a molecule, if we have an anion, which is a negative ion, make sure you add one electron because that whole ion has gained one or two. And for a cation or a positive ion, make sure you subtract an electron because that's why the overall ion is positive. And we'll take a look at a few examples when dealing with that. Do not worry about keeping track of which electrons came from where, only the total number is important. Write the symbols for the atoms, show which atoms are attached to which, and connect them with a single bond. Or of course 1-, remember, is 2 electrons. Chemical formulas are often written in order. So for example, HCN will have an H attached to a C attached to an N. So quite often they are written like that. In many polyatomic molecules and ions, the neutral atom is usually written first, or the central atom is usually written first. So something like the carbonate ion, CO3 2 negative. C is the middle ion, the middle atom, and the 3 oxygens are around it. Sulfur tetrafluoride, sulfur is the middle atom and F's are written around it. Remember, the central atom is generally less electronegative than the atoms surrounding it. So the electronegative atoms surround the weaker one, pulling the electrons away into their area. So a couple of things could be written in order, or use your table of electronegativities to see which is the lowest electronegative atom, and that'll be your central one that you'll be looking at. In other cases, you may need more information, and I will give you hints if I feel that you need it so that you know which way to draw it. Complete the octets around all of the bonded atoms to the central atom. So remember, however, that hydrogen atom has only one single pair of electrons around it. And another thing to note about hydrogen, if you take a look here, let's go back one page. I'm just typing in something here. So if you usually H is on an end. So since it only needs one electron, chances are it's going to be on the end of a molecule. So that's one other thing to consider there. It's on the end because it only needs one electron. So it's kind of a rule of thumb. You wouldn't put H in the middle because it's only going to be sharing one to get one. Okay, so you complete octets around the surrounding atoms first, and then you look at the central atom to see what's happening, and that's number 4. Place any leftover electrons on the central atom, even if doing so results in more than an octet of electrons around the atom. So we will find out there are exceptions to the octet rule, and it has to do with that central atom. Sometimes the central atom gets more than it needs, 8. A couple of the atoms, such as boron, requires only 6. So and I will inform you of exceptions like that, so you won't have to worry about it. Number 5, if there are not enough electrons to the central atom to make an octet, try multiple bonds. Use one or more of the unshared pairs of electrons on the atoms bonded to the central atom to form double or possibly triple bonds. So if it isn't one of those exceptions, take a look. Do you need to have a double bond? Share 2 to get 2, or share 3 to get 3. All right? So that's kind of the rundown as to the method in making Lewis structures, something that we didn't know previously, but now we do. So hopefully we can make that work with these examples. So if you take a look here at the first example, PCl3, draw the Lewis structure, and then following these 4 steps there. So of course the first step was to sum up all of the valence electrons. So of course, if we look at PCl3 and look at the periodic table, PCl3, of course P is group 5, so it has 5 electrons. Chlorine is group 7, so it has 7 electrons. All right, so that's how they get that. So we have 5 electrons, and we only have 1 phosphorus, so just one number 5. Each chlorine has 7 electrons in its outer area, and of course we have 3 of them, so we have to multiply that by 3. So 3 times 7 is 21, plus 5, 26. So there's a total of 26 electrons that we're going to place. And again, it says here, don't worry about which atom has which electron for now. We're just simply finding out the total. Second one, it says here, so arrange the symbols to each, etc. And if we take a look here, one of the things that was mentioned as the lower electronegative atom is going to be the center one. So comparing P and Cl, we know just from trends, P, Cl, as we go left to right, the ones on the right have the higher electronegativity, so that means P is the lower electronegative one, so it's going to go in the center. And then, of course, attach a Cl to each side of that P. All right? And then, of course, it says here, complete the octets around the outside atoms, so the ones that are joined to the central one. So 2, 4, 6, 2, 4, 6, 2, 4, 6. So in total, we've used, let's see, including the bonded ones, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I still have 26 left over. And then lastly, so I have 2 electrons left. The remaining electrons go around the central atom. And hey, that works out perfectly because now P has 2, 4, 6. And now that lone pair there, 8. So this structure gives each atom an octet. So you would stop at that because everything has an octet. All the chlorides have 8, and the phosphorus in the middle has 8 as well. So not too terribly difficult. If you look at this next example on the next page, how many valence electrons should appear in the Lewis structure for CH2Cl2? And this is a case in which the formula represents the order in which things happen here as well. But even if we were to look there, hydrogen, kind of a hint there, it's going to be off of the edge. Carbon and chlorine. Of course, carbon's over here, chlorine's over here, so carbon is less electronegative. So, of course, it's going to be our central atom. Now, how do we get this? Take a look here. 1 carbon, 2 hydrogens, 2 chlorines. So a carbon, of course, is group 4, so 4 electrons. H, of course, is 1. It's in group 1, so 1 electron, but we have 2 of them, so you have to multiply by 2. And then lastly, chlorine is group 7, so of course that has 7. But we have 2 of them, so you got to multiply that. And so that's a total of 20 electrons we need to place around here. So first of all, we would attach like this. We could have had the chlorine and H switched here. It doesn't really matter. So hydrogen, so we bond each of those outer elements to the middle one, and then we start placing electrons around the edges. Now hydrogen doesn't need any more. Once it's bonded to one thing, it's over. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 pairs of electrons. Or you can count them individually, it doesn't matter. Okay, so that's how we do that. Another one here, HCN. Of course, hydrogen is going to be on an end, so C and N will be bonded together. So, of course, counting them up, hydrogen is 1, carbon is group 4, so those 4 electrons, and nitrogen is a group 5, so we have to have 5 electrons. So that's a total of 10 electrons around there. So just put them together in a line, join the outer atoms with the middle one. So here we have 2, 4, 6, 8, 10. We have to place 6 more electrons around. So place them around the end first of all. Just like that, 2, 4, 6, 8, 10. So we have 10 electrons, but of course carbon is not satisfied. See up here, carbon had 2, 4, 6, 8. It needs to be attached to 4 things to be stable. So here we need to do something. As mentioned earlier on here, I talked about if that central atom does not have an octet, try multiple bonds. So we'll do that when we come back in the next video.